Okay, here we are on Excel, and there are a few things that we can do first. So I just copied my PowerPoint here, and what I want to do is I want to just write down these constraints and objectives here. So I want to say here objective function, and that's my objective, and I will highlight that, and that's maximizing investment return, and that is defined as 0.07 x1 plus 0.11 x2, 0.19 x3, 0.15 x4. That's how it is defined. So I just wrote it down like this. And I also need to write the constraints here. So I'm going to write here the constraints. And I have constraint 1, or the first constraint, C1, is trade credit. That's the investment. And X1 has to be less than or equal to 1 million. That's a maximum investment constraint. The same with bonds, gold, and construction loan. And then C5 is X3 plus X4 has to be greater than or equal to 0.55 X1 plus X2 plus X3 plus X4. And I just wrote it there. The same with the C6, minimum construction loan. It has to be at least 15%. So I'm going to put that there. And then last one, this one is not specified very clearly, but you have to catch it. You know, the total investment that you have is $5 million. So X1 plus X2 plus X3 plus X4 is less than or equal to $5 million. And lastly, there's non-negativity constraint. So that's one thing that you can do. And once you do that, now you need to write this down, right? So let's do this together. We need to formulate this one in a format that we can use Excel solver to solve this linear programming problem for us. You know, doing it with our own hands is too complex. So we want to use a software. And to do that, we first start with variable. Right, so variable, what we have is x1, right, x2, and x3, and x4. Right, we defined x1 as trade credit, x2 corporate bonds, x3 gold stocks, and fourth construction loans is x4, and that we want to put there. And we assume that this is the solution. So I'm gonna just give a just empty space there, and this highlighted area is the solution that we want to find. This is the portfolio that we want to derive from this question. And then we want to put now coefficient here. So objective coefficient. Let me make it bigger. And as we know, the objective coefficient is 0.007 for x1, so 0.07. For x2, 0.11. I'm sorry. For x3, 0.19. For x4, 0.15. Right? So this is our objective coefficient. So 7% return for x1, 11% for x2, and so forth. And we have here objective function. Objective function is simply this one, 7% times however much money you invest for x1. So that's M5 times M4 plus N5 plus N4 plus O5 times O4, and lastly 0.15 times this, right? So that this is your objective function. I'm just putting this mathematical formula into Excel a spreadsheet. That's what I am doing. So, and I'm gonna say this is very important. How much profit are we going to be able to get after getting this portfolio, the best portfolio? So that's what we want to see. And this is objective function. And then we have constraints. We have 8 constraints, and I'm going to say C1 is trade constraint and so forth. So I'm just copy this from here. So trade constraints, bond constraints, gold constraint, and so forth we have, and we are going to write here the coefficient for that, right? So for trade, we know that is 1, right? So 1 times x1, 1 is hidden there, and then these are all zeros, so I'm gonna put, and here we have to have left hand side, so left hand side volume, and then the sign, and right hand side, so that you need to put. And left hand side is again this times x1, right? So remember that empty cells that we are going to be using, we are going to assume that that's the x1 that we want to find, plus this times x2 plus this times x3 plus that times x4, right? That's, I'm just writing this formula down, right? x1 plus 0,000 is less than equal to $1 million. That's what I want to write, and that's the left hand side. And sign is right here is less than equal to, sign is very important, so be careful not to make a mistake there. So less than equal to, and right hand side is that the constraint is $1 million, right? So $1 million I'm going to write there. And bond is, we have a coefficient of 1 for x2, and then we have this one. So writing all this formula down is not a little bit cumbersome. So what I'm going to do is I'm going to use a function called the sum product, which does the same thing for us. If you are not familiar with that, then you can just use this way of this times that plus, this empty space plus this times empty space. You can use that, that's fine, but it takes time, and it's kind of repetitive. So I want to just use a function to save me some time, and that's less than equal to, and that was 2.5 million. Right, so that's 2.5 million, and gold 3, 1 here, and left hand side. So I'm going to use a function called sum product. So what this does is that first they multiply the cells together and then add them up. That's a sum product function. So what I'm going to do is, these are the coefficients that I want you to consider, and then add them up. So sum product. So it's much easier to take care of this solver format, right? And then I can also say less than equal to, and then that is 1.5 million. And then we have fourth one is X4 construction loans, and left hand side. When I can just copy this down. However, when I copy this down, what happens is that this the variable cells are moving down as I am copying it down. So what I can do is I can fix that area by saying, I want you to fix this is not right. So M4 to P4, I need to fix that. So cell 4 and P4, fix that, right? Don't move it. And then just scroll down. So row is fixed. And then as you do that, you see that M4 to P4 is just fixed. By using $, you can make semi absolute reference, and doing so you can use your formatting much easier. Now, so construction, this one also has to be less than equal to, and then that's $1.8 million. And then C5, x3 plus x4. So x3 is 1, x4 is 1, and then this part we already entered the formula, so we can go there. That has to be greater and equal to 0.55 x1, x2, x3, x4. So it's a bit complicated. So we have to solve, move all these x1, x2, x3, x4 to left hand side. So what happens if we subtract 0.55 x1, x2, x3, x4, and then on the left side you have to subtract 0.55 times x1, x2, x3, x4. So what happens here is negative 0.55 here, right? Negative 0.55. But here 1 minus negative 1.55 is 0.45. It's positive, and this is positive, right? And this one has to be greater and equal to 0, right? Because you have moved them to the left. And now look at x1 is greater than 0.15 times x1 plus x2, x3, x4. So if you subtract 0.15 parenthesis x1, x2, x3, x4, then the right side is going to be a 0, but left side x1 minus 0.15 is going to give you 0.85, right? So x1 is going to be 0.85, but here negative 15 x2, be careful, negative 0.15 and negative 15 and negative 0.15, and that's going to be greater or equal to 0. Okay, so another one. Okay. And total investment x1, x2, x3, x4 has to be less than equal to $5 million. And we have non-negativity constraint. And now if you have that, you are ready to run your Excel result. So let's do that. So I'm using MacBook, and I downloaded Office 365. I'm using Excel Office 365. And if you go to data, here you will see analysis tool pack, right? And click on it. And then I encourage you to check on all of them, especially if you uncheck them. So solver add-in has to be there, and I also encourage you just check on them so that you can load Excel solver there. And OK, and then you will see data analysis and solver icon, and click on solver. And then it gave me another window where you are going to put all this cell information there. So set objective. So objective is right here, right? Our objective is to maximize our return. So that's what we want to do, and then choose that if you are maximizing or minimizing, and your choice is maximization. And changing variables, are M4 to P4, right? This is what is changing. And we also want to add these constraints, subject to the constraints. So add, and you go to left hand side and sign, and right hand side. So just be careful to pick the right cell. So the first one, the first constraint, trade, and less than equal to, and the right hand side is 1 million. And if you have done that, or if you click just OK, then you will see the first constraint is added on this Excel solver parameters. And if you want to add another one, click on add, and then the second constraint you can add like that. You can hit OK or just hit add, then you can go to the third constraint right away. So third one, and less than equal to 1.5 million, and add. Fourth one, this, and constraint that, add. And then fifth constraint is right here. And notice that the sign is different, so make sure that you change the sign. And right hand side right here, add. And then we have sixth constraint, change the sign, and right hand side constraint. And another constraint is this seventh constraint, and that's less than equal to, so which is good. And then right here, and if you have done that, you enter the 7 constraints and make sure 1, 2, 3, 4, 5, 6, 7 constraints are added, and the cell number has the same pattern. There's nothing that I did wrong, so that's a very good thing. Now here, make unconstrained variable non-negative. So this is a non-negativity constraint, so you check on that. And then here, what kind of method are you going to use? We are using simplex linear programming method, so I encourage you to check on simplex LP and then click on solve, right? If you have done that, now you're ready to solve it. So solve. And it is solving. It has solved it actually. And then you can get answer and sensitivity analysis result. And click on OK. So then you see answer report and sensitivity report here, and your original sheet. So I'm going to change the name, portfolio analysis selection, ICT, right? So I chose them, and this one, especially if you come over here, they found the variables. What is the maximum portfolio it is? So for X1, trade credit $750,000. For X2, $950,000. For X3, gold stocks $1.5 million. And X4, construction loans $1.8 million. So that is the best allocation of the money out of $5 million, and that's what we have found. And it also said, when these are the determined or best portfolio at the time, how much money are you going to be able to make, right? That's about $712,000. Will they be able to make money? So considering that they invested $5 million, a lot of money they earned, right? So that's what we can see there. $712,000 of almost $1 million they have made money, close to 20%. So that's a lot of money.